Hello guys, today we are going to talk about slab reinforcement estimation. So from this design, we will find out how much rebar we will need to reinforce the slab. To find out the total number of rebars, we have to first look at these legends. In these legends, the number 1 is saying that hashtag 4 at the rate 6 inches C/C alternative crank. So this means these bars need hashtag 4 bar designation. This is the bar designation, and the 6 inch is actually the spacing between straight bar and crank bar. We all know that alternative crank bar is actually defined from a straight bar and a crank bar. From in this design, you can see there is a straight bar and then there is a crank bar. So this is the main goals of this alternative crank bar. So from this legend 1, we have to find in number 1 from this design. In any kind of design, you have to just look forward like this. So from this number 1, we can see that this straight line is going up here, and this actually connecting is this 2 dot. So from this 2 dot, we have to actually calculate how much bar we need. So from this straight line, we can see this is that the first dot is actually cross out. So from this cross out, we have to actually calculate the number of straight bar we need there. So I made a table here, so you can see that bar designation. You can actually use this table for any kind of estimation you need. So from this bar designation, we have to hashtag 4, we have to put this hashtag 4 because we know that this legend is saying that we need hashtag 4 rebar. So hashtag 4 rebar, the first one is come out that the straight one. So first we have to calculate that what the number of hashtag 4 bar designation straight bar we need from this destination. Okay, this is the destination, how much bar we need to cover up this area, and the length we have look for right from the next calculation. So first we have to just put the number here we actually given through in this design. You can see that 1 feet 9 inches for the cornice, then 10 inches for the walls, then 20 feet, then 10 inches, then 9 feet, then 1 feet 9 inches. So after calculating this, we can find out that this total length is actually 34 inches 2 feet, 34 feet 2 inches, 34 feet 2 inches, and then we have to deduct 2 inches and 2 inches from both of the sides. We are actually deducting 2 inches from both sides because of spacing. We can see from this side we are deducting 2 inches, from this side we are deducting 2 inches. We are deducting this 2 inches for spacing, and we need to do this for all kind of design you will get in future. It actually work in every project, but the deduction measurement will be varies from side to side, but you have to deduct the amount for spacing. So after deducting it, we have to divide it by 12. So the question is, why is 12? The spacing is actually saying that 6 inches, but why are we actually deducting 12 inches? The reason is we know that there is the spacing is actually one straight bar to one crank bar. The spacing given is from this portion is actually 6 inches. Okay, but what if we actually put another straight bar here? So 6 inches plus 6 inches, this is going up to 12 inches, because first on alternative crank bar we are going to measure the straight bar, then we are going to measure the crank bar. So the spacing is actually here is 12. The number is just 12. There is no feet. This is actually 12 inches because you can see that we are given 6 inches here. So now we are putting here is 12, then we have to plus 1. Why we have to plus 1? Look at that. If we put a straight bar, then a crank bar, then a straight bar, so then another crank bar, so the last one we have to just put it 1, then we will actually finishing up the total calculation. That's why we actually put up 1, and then if we finish the calculation, we are getting that the 35 number of bar we will need for the straight bar. This straight bar will need for this length. Okay, so we having those. Now what we need is the length. How much length of this straight bar is. Okay, so this is the length, and this is the number of total bar we need. So to calculate the length, we just to put this 1 feet 9 inches plus 10 inches plus 22 feet, then this 10 inches, then 22 feet, then again this 10 inches, then 1 feet 9 inches. It's very easy. And if we plus this, then we can find this 50 feet here. Then now again we have to deduct this 2 inches and 2 inches from each of this side for the spacing. After deducting it, we are going to get 49.67 feet. Then we have to multiply this length to this number of bar. Then we can find the total length. Again, we come here for the crank, again on the bar designation of hashtag 4. So this is very simple. Now the going through is for the long direction is very easy. We're actually working for the long direction. This is the long direction and this is the short direction. So now crank bar, the number of bar we just need to deduct it from the number we get from the straight bar. How is possible? Look at this. This is the straight bar, then this is the crank bar, then there is straight bar, then there is crank bar, then there is straight bar. So if we get that there is 1, 2, 3 number of straight bar we find here. So if we minus 3 minus 1, then how much number we get? 2. So look at that, there is 2 crank bar. So that's how we can actually find out the number of crank bar from the straight bar, just deducting it by minus 1. So we get the 34 number of crank bar we need for this plan, and now we have to find the length. So this is there is some little confusion about this formula. I will explain it very easily. So we have find that 49.67 feet length. So the length will be, we have to adding this length from straight bar we get here. Now the problem is that we have this bend here. That's why it's called crank bar. This bend, we have to measure the length of this bend. Okay, so because this length is actually getting some extra length. So how we can actually manage this? There is a formula here, 4 into 0.42. This 4 is actually the number of crank bar, the number of crank actually in this bar. We have 1, 2, 3, 4. If we have just one, this two crank, then we will put there 2. So we have 4 crank here, so we actually going to put 4 in here. Then 0.42 is actually a constant. You can see from here 0.42 is actually a constant, and there is the length, and then again 0.42 d. So what is the d? D is actually, you can see that there is 4 divided 12. So what is the 4? The 4 is actually not that the crank bar number, is actually the slab thickness, and then we will minus it by the cover. In every design you will given the slab thickness, then you will given the cover, so you have to minus it from the slab thickness to the cover, then you can find out the number t. Then we divided it by 12. The 12 is actually converting it inch to feet. That's a simple. Don't get confused about this 12. Is actually, we are actually converting inch to feet. This is in inch, so but divided it 12, it will convert into feet. So now we are going to get it the 50.23 feet. Now we will multiply it by 34, then we get the total length. Then again we have the extra top, #4 extra top. From where we get this? Look at that legend 2 #4. 2 #4 means it's actually putting 2 number of extra top in single point. And then there is between crank bars. Between crank bars mean in between there. You can see that there is an straight and then there is crank, so we are actually put up 2 extra top in between them. So the calculation is very simple. We have to just minus it from the number we get in the crank. In any calculation you have to just deduct -1 from the number of bar we get from the crank estimation. Then we have to multiply it 2. Why we multiply it 2? Because it's saying that 2 #4. If there is no 2 if there is no 2 put it up here, then we are not going to add those 2. So there is 2 is given, so we are going to multiply it by 2, then we're getting the 66 number of bar. Now the length is also very easy, so we have to find out from the design that this line is actually crossing this little segment. You can see, so this little segment is giving up the L1/3, L2/3, and then there we have a 10 inch wall. This between, you can see this L1/3 is actually ended up in here, this L2/3 is actually ended up in here, and then there we have a 10 inch in the middle of this segment. So what happened? What is L1? You can see there is given that L1, there is the L1 and there is the L2 and there is the L3. So what is L1? L1 is actually 22 feet, L2 also 22 feet, and L3 is actually 20 feet. So the calculation is very easy. We have to just put 22 feet by divided 3 plus 10 inch. Then what is L2? 22 feet, then 22 feet by divided 3. So here is the 22 feet divided 3 is, we have to actually put divided here, then we have to put divided here, then plus 10 inch, then we can actually, we are going to get 15.5 feet, then we have to multiply it by 66, then we are getting the total length 643.50 feet. Then we have to again look at that legends. Always find the legends, then you can, it will be very easy for you to actually calculate the slab reinforcement estimation. Then what we get that #3 extra top in between crank bar. So the bar designation now changed, is #4. So it's actually saying that this, we have to just put 1 bar in between crank bar. So what happened in 3, we have to find out from the design. So what is here in 3? So there is a 3 line and also there is a 3 line. So what happened that we have to put 2, just 2, and L1/3, L2/3. So let's look out that table, #3 extra top. Again, number of bar, we just have to deduct it -1 from the crank bar. From this crank bar, just -1, then we get the crank 1. Now why are we actually putting 2 here? Because in design we have this 2 extra top in the both of this side. You can see, if there is just 1, then we are not going to put the 2 in there. So because of there is 2 side in there, so we have to put 2 in there. So now we are getting 66, and now the length. So the length is actually very easy to find out, the L1/3. So there is some confusion that is actually going out through the cornice. So you have to put 1 feet 9 inch minus 2 inch, because we have to deduct 2 inch because of spacing. Whenever the calculation is goes beyond on the side, then you have to minus it 2 inch, or the given inch, the spacing measurement, you have to minus it. So then 1 feet 9 inch minus 2 inch plus L1/3. So what is L1? 22 feet divided 3. Then again come here, L2/3. So 22 feet divided 3 plus 10 inch plus 1 feet 9 inch, then minus 2 inch. Look at her here, 1 feet 9 inch minus 2 inch plus 10 inch plus 22 feet 3, 9 feet, 9.75 feet. So what we actually did here is the same as belong the one side. If you just calculate it in one side, then it's actually getting the other side also. So now we have to just multiply from 66 by 9.7. If you have a confusion that why we actually not plusing is because we have a 2 in here, because the length is actually same for the both side and we are actually putting 2 in here, so it's actually multiplying the 66. Then if we multiply 9.75 feet with 66, then the length is actually we are getting for the both side. So now the length is 1023 feet. Then we have to look at the hook. What is hook? Hook is actually the thing that if you see that there is some extra portion is actually cranked out or bent up, this is the portion which we call the hook. So in every bar at the ending there is a hook, and we have to put this hook for all of the bars. You can see that there in this design everywhere there is a hook, So from #3, so how we will find out the hook? So we are going through the designation. So we have #4 designation and #3 designation. If there is #2 designation, then we have to also find for the #2 designation hook. So first check out that #3 hook. So what happened that the #3 hook, we just got one #3 hook, and this is the 66 number. So number of 66 hook we need, and for those both sides. Why we are multiplying 2? Because if we actually putting this is an bar, a straight or crank, doesn't matter. But if we put hook, then the hook is actually gone for both of these two sides. For single number, there we are actually having 2 number of hook. So that's why we're actually putting 2 in there. So 66 into 2, 132. So now the there is what happened is actually the length of this hook. So this number is actually constant, is actually level up from 9.5 to 12. We have to put 10 for the standard method. We have to 10, then we have to put 3 divided 8. 8 we all know that the diameter we have to 3 divided 8, then into 1 divided 12. So 1 divided 12 is actually we are actually again converting inches to feet. This all are in inches, and this is actually in inches, and this actually have no, this is just 10, there is no thing there. So we are just actually into with 10 and then converting into feet. So this is 0.3125 feet. Then we are actually multiplying it with 132. Then we are going to total length. Again on the #4 hook, we can find it from the #4, then #4 crank, 34 plus 35, then #4 extra top 66, 35 plus 34 plus 66 into 2, 270. Then again we are having this hook is 4 diameter, 4 divided 8 into 10 into again 1 divided 12. 1 divided 12 is actually we are converting it to inch to feet. So then we are actually getting 0.417 feet. Then we are multiplying it to 107. Then we are getting 112.59 feet. Now there is short direction. So what happened that we are actually all coming up. We are done with the long direction. How we will find out that we are done with the long direction? From look at after the legends. If you see that number 4, we are actually done with the number 3, then we have to look at number 4. If we found out the number 4, this is the straight line of number 4, and if you can see, this is actually cross out this dot line, and this dot line is actually following through this straight bar and this crank bar. So again there is actually the same method going through from we did in the long direction. We have to first, we just have to change the direction. So the number of bar is actually from this portion. This portion is actually for the number of bar, and this is the length. Okay, so this is the length. So things are actually the same, but just the direction is actually rotated. So again we have to 50 feet. So how we get the 50 feet? By adding those numbers. We are getting 50 feet, then minus 4 inch from both sides because of spacing. You can see minus 2 inch, minus 2 inch. Then we are actually dividing 8 by 8. Why 8? Because you can see that the spacing is actually saying that 4 inch. So what happened that one straight bar and one crank bar is actually 4 inch. So what happened about one straight bar? This is the crank bar, and one straight bar to one straight bar is actually having a space of 8 inch. So that's why we actually put up here 8, then again plus 1 like the above calculation. So we are getting 76. Then again 34 feet 2 inch for the length of this direction. 34 feet 2 inch. Then we are actually deducting 2 inch from both sides for the spacing. Then we are getting 33.83 feet for the length for the short direction of the straight bar, which bar designation is #4. So now we are multiplying this 33.83 feet to 76. Now we are getting 2571.33 feet of total length. Then we are getting the cranked. So again from crank we have to just deduct it from the number we got from straight bars. Number of straight bar we got the 76. We have to just deduct it from -1. Now what happened that we have to calculate the length of this crank bar. So what problem we get from crank bar, that there is a crank length, we have to just measure this length. So what happened that we have to first add the number we get from the straight bar 33.83 feet, then plus 4. So there is some calculation mistake. We just have to put it 2 in here because we get 2 crank bar in here. Now we have to 0.42 as usual. This is very constant. Then why actually put here 3? No 3. This is actually again 4 because we have to slab thickness we have to minus 5 inch from 1 inch because 1 inch is the cover. in every project you will get the slab thickness it almost for 5 inches or 6 inches for the most of the cases. Then you have to deduct it for the cover which is actually 1 inch. Everything will be given in the design. If you are just calculating the reinforcement bars, so then the thing is very easy. So again we are getting it 34.13 feet, then we are actually multiplying it 75, then again the extra top, where we are actually getting the extra top from the legend number 5. So 1 hashtag 4 extra top in between crank bar, so between crank bar it will getting 2, so we have to just deduct it from the number we get from crank bar. So 75 minus 1, 74. Then we have to look at that number 4. What we got in number 4 is, you can see this is the we actually working on number 5. So from number 5 you can see this is the number 5, and yeah, just there is just one number 5, and this is L3 divided 3. So we have to just put 1 feet 9 inch plus we have to put 9 feet, then plus 10 inch plus L3 divided 3. L3, what is the value of L3? L3 is 20 feet. So you can see we can find out that 1 feet 9 inch minus 2 inch plus 9 feet plus 10 inch plus 20 feet divided 3. So we are getting 18.08 feet. Again multiply it by 74, then again extra top for what the last lesion we got 1 hashtag 3 extra top in between crank bars. So there is the number 6 line. So this is the L, this is we are actually getting the L3 divided 3 plus L3 is actually 20 feet. They actually didn't put the calculation value here, but we have to just, it's very simple. This is actually putting here. So L3, first put the L3 divided 3, then plus 10 inch, then plus 1 feet 9 inch, then minus 2 inch for spacing. This is very simple. So 1 feet minus 2 inch plus 10 inch plus 20 feet divided 3. So we are getting 9 feet 8 inch, then multiplied by 74, we are getting the total length. Then again the hook hashtag 3 we get 76 plus 75 plus there is a extra top 74 into 2, because both of the sides the hook is actually attached. Then we getting 455, we have to multiply it by 0. Again 10 is the constant number, which is a value is or a standard mark is 10, but the calculation you can take the value from 9.5 to 12.5. We are actually taking 10 into 3 divided 8, which is actually the diameter, into 1 divided 12, which is actually we are converting inch to feet. Then we are getting 3.0125 feet. Then we are multiplying it by 450. Then we are getting the length 140.62. Then again the hook 74, because there is just one hashtag 4 hook, which is 74 into 248. Then 10 into 4 divided 8 because of the diameter. Then we are actually again putting it into inch to feet. Then we are getting 0.417 feet, and we are multiplying it by 148, and we are getting length 61.716. So now we can actually get the part designation hashtag 3. So we have to just put all the hashtag 3, that getting 103 feet 5.04, 1038.16 and 140.62. So we are getting the total length of hashtag 3 bar is 6642 feet, 6642 feet. And also again the hashtag 4 or the hashtag 4 designation, bar designation, we have to put 170.38, 707.70, 643.50, then 112.59, then 672.16, and again 61.716. So we are getting all the total length from here, and that's how we can actually calculate the total slab reinforcement estimation. How much bar total length of bar we will need. You can actually convert it by pound, how much 1 feet pound is 1 feet length of bar is actually weighted. Then you can actually multiply it by the rate, and you can actually find out you can actually estimate the total cost of the slab reinforcement. It's very easy, and thank you so much.